Hi there! This video is here to help you calculate the area of a triangle by counting squares. Remember, the area of a shape is the measurement of the space inside it. Area is written in squared units of length, such as centimetres squared or metres squared, and is written like this. If a shape is drawn on a square grid, we can count the squares to calculate the area. When counting the squares, it's a good idea to mark them off as you go to make sure you don't miscount. For example, we can count the squares in this rectangle to see that its area is 12 centimetres squared. It is slightly more difficult to calculate the area of shapes which are not only made up of whole squares. Let's look at this triangle. We can count all of the whole squares first. There are 6. However, there is still some area inside the shape which has not been counted. In this triangle, we have 4 half squares, which we can add together to make 2 more full squares. The area of this triangle is 8 centimetres squared. Use this method to work out the area of these triangles. Here are the answers. How did you get on? Remember, you can always rewind the video to see how you should have completed this calculation if you need some more help. Sometimes a triangle contains parts of squares that are not exactly half. In these cases, we need to make an estimate of the area, thinking about which parts might come together to make approximately a whole square. Approximately means we cannot be sure of the exact area, but have made a good mathematical estimate. For example, in this triangle, we can start by counting the whole squares. We can then group together parts that look as though they might make a whole square. I've used colour coding to show how parts of the squares might come together to make a whole. These parts make approximately 4 squares. Added to the 8 whole squares, this means that the area of this triangle is approximately 12 centimetres squared. Use this method to work out the approximate area of these triangles. The first triangle had an area of approximately 10 centimetres squared, and the second triangle had an area of approximately 6 centimetres squared. Well done if you got that one correct. To finish, what do you notice about the areas of these two shapes? Pause your video now to come up with an answer. The area of the rectangle is 16 centimetres squared. The area of the triangle is 8 centimetres squared, which is half of the area of the rectangle. If we put 2 identical triangles together, we can see that they have the same area as the rectangle. Do you think this is always true? Make sure to watch our area of a right-angled triangle video to find out more. I hope this video has helped you to understand how to figure out the area of a triangle by counting squares. We have lots more videos on the Twinkl website, including other videos all about finding the area of a right-angled triangle, so make sure to check them out. Thank you for watching. Hi there! This video is here to help you with calculating the area of a right-angled triangle. When we calculate the area of a rectangle, we use the formula area equals length multiplied by width. The area of this rectangle is 6 multiplied by 5, which equals 30 centimetres squared. We can divide any rectangle into 2 identical right-angled triangles by joining the diagonals like this. Remember, a right angle is a 90-degree angle and can be marked in a shape using little squares like this. Because we have divided the rectangle in half, we have also halved the area. The area of each triangle is 30 divided by 2, which is 15 centimetres squared. Let's use this information to create a formula to calculate the area of any right-angled triangle. In a triangle, we call this side the base. The base doesn't need to be at the bottom of the triangle, but it can help to rotate your triangle so that it is at the bottom. The base of this triangle has a length of 6 centimetres. This side is called the perpendicular height. Remember, two straight lines are perpendicular if they meet or cross at a right angle. This side is perpendicular to the base, so it is the perpendicular height. The perpendicular height of this triangle is 5 centimetres. It is worth noting that the base and perpendicular height can be either way round, as long as they are the two sides of the triangle that meet to make the right angle. We find the area by multiplying the base by the perpendicular height and then halving it. We can write this as a formula. Half multiplied by 6 multiplied by 5. We know we can do multiplication in any order, so we can calculate 6 multiplied by 5 first, and then multiply it by a half, which is the same as dividing by 2. 6 multiplied by 5 is 30. 30 divided by 2 equals 15. The area of this triangle is 15 centimetres squared. Let's apply this formula to a new triangle. This triangle has a base of 4 centimetres and a perpendicular height of 7 centimetres. Half multiplied by 4 multiplied by 7 equals half multiplied by 28, which is the same as 28 divided by 2, which is 14. The area of this triangle is 14 centimetres squared. Now it's your turn. Use the formula area of a triangle equals half times base times perpendicular height to calculate the area of these right-angled triangles. Remember, the base and perpendicular height are the sides of the triangle that meet at a right angle. The base doesn't have to be at the bottom of the triangle. If you're finding it hard to identify which sides you need to multiply, unpause and wait for the labels to appear, and then pause again to calculate the areas. Here the base and perpendicular height have been labelled. Remember, they could have been the other way around. The important thing is that they are the sides which meet to make a right angle. Here are the answers. Well done if you got them both right. Remember, you can always rewind the video to take another look at how you should have answered these questions. We can also work backwards and use the area of a triangle to work out the missing base or perpendicular height. See if you can use the formula to calculate the perpendicular height of this right-angled triangle using the information you have been given. We can put what we know into our formula. 30 equals half multiplied by 10 multiplied by perpendicular height. Half multiplied by 10 equals 5, so 30 equals 5 multiplied by perpendicular height. We know 5 multiplied by 6 equals 30, so the perpendicular height must be 6 centimetres. Well done if you got that one correct. I hope this has helped you to understand how to calculate the area of a right-angled triangle. If you need more maths help, we have lots of these videos on the Twinkl website, so make sure to check them out. Thank you for watching. Hi there! This video is here to help you find the area of any triangle. If you haven't already, you might want to watch our video all about finding the area of right-angled triangles first. In that video, we find out how to find the area of a triangle by calculating half multiplied by base multiplied by perpendicular height. In a right-angled triangle, two of the sides were perpendicular to each other, so we can use these measurements in our formula. This is not the case with every triangle. For example, let's look at this one. None of the sides of this triangle meet to make a right angle. If we take the bottom horizontal line as the base, we can mark the perpendicular height by drawing a vertical line from the base to the opposite corner, like this. Now we have a perpendicular height. The area of this triangle is half multiplied by 8 multiplied by 6, which equals 24 centimetres squared. Sometimes the perpendicular height isn't inside the triangle, like in this example. Here we can extend the base so that it is directly beneath the corner at the top of the triangle, making a right angle. When we use the formula, we take the actual base of the triangle that we started with, not the extended length. So the area of the triangle is half multiplied by 8 multiplied by 3, which equals 12 centimetres squared. One important thing to remember is that the base of a triangle isn't always at the bottom. The key thing to check is that the base and perpendicular height must meet to make a right angle. Here are some examples of different triangles with the bases and perpendicular heights labelled. When working on paper, you may find it useful to rotate your paper so that the base is a horizontal line, like this. Now it's your turn. Using what you've learnt, calculate the area of these triangles using the formula area equals half times base times perpendicular height. Here are the areas of the triangles. Well done if you got them all correct. If you need to have another look at how you should have figured these out, you can always rewind the video. Time for a final challenge. What is the area of this shape? Use what you know about calculating the area of rectangles and triangles to help you. Here is one way you could have worked out the answer. To start with, you could have divided the 20 centimetres by 4 to work out that each of the squares has a side length of 5 centimetres. This means that each of the squares has an area of 5 multiplied by 5, which is 25 centimetres squared. There are 6 squares in total within the shape, so the area of the squares in total is 25 multiplied by 6, which equals 150 centimetres squared. The triangle has a base of 10 centimetres because it is equal to the length of 2 squares. The perpendicular height is 5 centimetres as it is the same height as one of the squares. This means the area of the triangle is half multiplied by 10 multiplied by 5, which equals 25 centimetres squared. So if you add the 150 to the 25, you will find the total area of the shape, which is 175 centimetres squared. Well done if you got that one correct. I hope this video has helped you to understand how to figure out the area of any triangle. If you still need more maths help, we have lots more of these videos on the Twinkl website, including more about finding the area of triangles, so make sure to check them out. Thank you for watching. Hi there! This video is here to help you calculate the area of a parallelogram. Before we start, let's recap the definition of parallel. If lines are parallel, it means that they are always an equal distance apart. Here are some examples of parallel lines. Parallel lines are sometimes marked with an arrowhead halfway along the lines, like this. If there is more than one set of parallel lines in a shape, then 2 arrowheads can be used, like this. A parallelogram is a quadrilateral or 4-sided shape with opposite sides that are parallel. Here are some examples of parallelograms with the parallel sides labelled. Rectangles, squares and rhombuses are all types of parallelogram. To find the formula to calculate the area of a parallelogram, let's look more closely at this parallelogram. We can divide the shape into a rectangle and 2 identical triangles. If we were to take one of the triangles and move it to the other side of the shape like this, we can see that we have made a larger rectangle. We haven't changed the area of the shape by doing this. We can see that the length and width of this rectangle are the same as the base and the perpendicular height of the parallelogram. So we can find the area of the parallelogram by multiplying these 2 lengths together. Remember, it is important to use the measurement for the height of the parallelogram that is perpendicular to the base. This means the 2 lines meet to make a right angle, not the length of the other side of the parallelogram. We can now use this formula to work out the area of the parallelogram. 7 centimetres multiplied by 4 centimetres equals 28 centimetres squared. We can apply this formula to any parallelogram. Sometimes it can be difficult to work out which measurements to use. When you've identified two lines that meet at a right angle, it might be useful to rotate your shape so that the lines are horizontal and vertical like this. The base of this parallelogram is 13 centimetres and the perpendicular height is 8 centimetres. So the area of this parallelogram is 13 multiplied by 8, which is 104 centimetres squared. Now over to you. Use the formula to calculate the area of these parallelograms. Pause here until you're ready to check your answers. Here are the answers. Well done if you got them all correct. If you still need a little recap, remember you can always rewind the video to see how you should have solved these. The area of these parallelograms is 24 centimetres squared. What are the missing measurements? Pause here to find the answers, remembering to check the units of measurement carefully each time. Here are the answers. The units on the second parallelogram were in millimetres, so need to be converted into centimetres so that all measurements had the same units. Well done if you got those ones correct. I hope this video has helped you to understand how to figure out the area of a parallelogram. If you still need more maths help, we have lots of these videos on the Twinkl website, so make sure to check them out. Thank you for watching.